So, all right, we're talking about objects on an incline. The good news here, how are you going to solve these problems? Step 1, free body diagram. Step 2, sum the forces. Step 3, work the algebra from the summing of the forces. Now, there's one key thing. Well, here on my list I have 2 key things. But the most important one is number 1 right here. Okay, when you're doing an incline problem, you want to tilt the XY axis. See, normally the XY axis is like this. You go to there's the X axis, boom, there's the Y axis. And look, if you really wanted to, you could keep the XY axis like this, untilted, the way it normally is. But if you do that, life is going to be much more difficult. And here's why. So which way is the acceleration? Let's look at this block right here on this hill. For the block going down the hill, which way is the acceleration? The acceleration is parallel to the incline, right? The acceleration of this block is parallel to the hill. So let's put that on the XY axis. You're allowed to pick vectors up and move them. So that means that our acceleration is the acceleration perfectly x. If we keep the XY axis untilted, would the acceleration be perfectly x? Nope. Would it be perfectly y? Nope. So the problem's solvable this way. You can do it, but here's what you'd have to do. What would you have to do to this acceleration vector? You'd have to break the acceleration into what? X and Y, right? So when you sum your forces, here's what the sum of the forces would look like. You'd be like, all right, sum the forces X, blah-bitty, 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 blah. It's different for every problem. Every problem is a different blah-bitty, blah. But then when you're done summing, what's it going to equal? You're going to go, okay, MA, but then you got to get this X acceleration. So what would that X acceleration be? It would be cosine theta A, right? And then you sum the forces in the Y. Blah-bitty, 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 blah equals M times, then you got to get this Y component for the A, which would be negative sine theta A. Does this look like fun? No. I mean, it's possible. You could do it. You could do it and it would work, but it'd be a lot more effort. So how do we make things simple when you're working on an incline? To make it simple, what you're going to do is you're going to go, okay, incline, here's what we're going to do. We're going to say that the incline is the x, right? Like that. Perpendicular to the incline is the y. Does that make sense? So what's really nice about this? The thing that's really nice is your acceleration is now going to be perfectly what? X. So what's the acceleration this way? 0. It's going to simplify your summing of the forces. You guys follow that? Maybe you have to watch the video at home, but that's the reason for what we're doing. We're tilting the XY axis. All right, so what I'm going to do is I'm going to set up an incline. So I'm going to erase this image, and I'm going to set up an incline from scratch so you can see how to do it. So let's say we have a hill. So here's our incline, and I'm going to show the angle. So say that this is a 30-degree incline. All right, that's a 30-degree incline. So we have a box sliding down the incline. So this object is going down the incline, and friction's present. We'll say that friction is present. So what are the forces acting on this block? Let's just label the forces so you can see how this works. So what force is going straight down? Gravity. Gravity is always straight down. So I label this mg because that's the equation for force of gravity. Now, is the object on a surface? Yep. So there's a normal force. And normal force is always perpendicular to the surface. That's why we call it normal force. Does everybody know what the word normal means? perpendicular to. So the normal force is perpendicular to the incline. And then if the block slides down the hill, which way would friction be? Friction would be up the hill, like this, parallel to the surface. Okay, so there's friction. Okay? Hey, what if, thanks. What if the block here were sliding up the hill? You're going to see that in the homework set. What if the block slides up the hill? Then which way would friction be? If the block were going up the hill, then friction would point down the hill, right? Friction is always opposite motion, parallel to the surface. Okay? Now, let's put in the xy axis. We're going to tilt the xy. So here's the x. Here's the y. And then let's also put in sign convention. See what I put here at number 2? For number 2, it's always nice to make the object's motion positive. So if the block is going down the hill, then make down the hill plus, up the hill minus, like this. Okay, so what, guys, what if you have a problem where the object's going up the hill? People in general, do they want to have their motion to the right or to the left? To the right. So if you're doing a problem in the homework set where the object is going up a hill, just draw the hill the other way, like this. So here's the object going up the hill, so then friction's back like that, mg's down, like that. You know what I'm saying? Just draw the hill the other way. Now, so we got our sign convention. Here's our xy. Okay, what is super nice about the normal force? There's something really user-friendly about the normal force. What is really nice about the normal force? It's perpendicular to the hill, which means that it's perfectly what? Y. See that? The normal force is perfectly Y. That's going to be easy when we sum the forces. Okay? Now look at friction. What do you notice about friction that's really nice?
Perfectly X.
It's perfectly X. Friction is perfectly X. So that's going to be really easy when we sum the forces. Now, the one thing that's always going to be a pain in the butt when you're doing an incline problem is mg. Because look at mg. Is mg perfectly X? No. Is it perfectly Y? No. So that means, what do we have to do to it? Break it apart. So we're going to go Y component, X component, like that. Okay, so this guy is mgy, this guy is mgx. You guys with me? Now, whenever you're breaking vectors apart, you've got to have an angle. So this angle in here, we can get. Just with a little bit of geometry, we can figure out what this angle is. So over here, this is a 30-degree incline. MG makes a 90-degree angle. So we have this nice triangle here. Everybody see that triangle? We got this nice triangle. So what's this angle in here? 60, because it's a 30, 60, 90. So what must this angle over here be? It's got to be 30, because this is perpendicular, right? So you're going to need an angle to break mg apart. So this angle in here it's always equal to the angle of the incline. That's 30 degrees. Okay, so now we're going to sum the forces. So I need to make some room. Let me scoot this over. Scoot over there. Okay, so summing forces X. So any questions so far? Okay, so we're summing forces X, summing forces Y. How many forces are in the X direction? And remember, the x direction is the incline. This is the x. How many forces are in the x direction? 2. What are they? mgx and friction. Those are the 2 x forces. Okay? Let's talk about mgx. If you look at this, now remember, you can pick vectors up and move them around as long as you don't change the direction. You're allowed to move a vector as long as you don't change the direction. Pick up mgx. In fact, let's do this. I'm going to pick him up. I'm going to pick up, here. I'm going to pick this vector up right here, and I want to show you something. What is mgx doing? That's the vector. That's what? What is mgx doing? Pushing the block down the hill. mgx is the force pushing the block down the hill. What's mgy doing? What is this guy doing? mgy is doing what? Pushing the block where? Into the hill. Right? Okay. I just want to show you that. Okay, so how do we get mgx? The thing that you don't want to do, that I've seen kids do this like 100 times, they come up and they're like, Spaldo, I don't know what I'm doing wrong. And you want to know what I've seen 100 times? This is a big no-no because it's not going to help you at all. When you're summing the forces, I've seen kids go like this. mgx, which is nice and all, but is that going to help you? No. So what do you have to do here? You got to put mgx in terms of mg using trig. So see, we got a triangle here. See that triangle? What's the hypotenuse of that triangle? mg. See the right angles right here? So we can use trig, just basic old trig. So what is mgx going to be? Sine 30 mg. What's mgy going to be? Cosine 30 mg. Right? So you got to use trig here. So summing the forces in the x, you're going to have sine 30 mg. Right? That's the force down the hill. Then minus friction. Why did I make friction minus? Which way does friction point? In the negative direction. Friction points up the hill. Okay? So, why can't I get this? So, what is the sum of the forces equal to? MAX. We just wrote a very useful equation. Yo.
How did you know that was 30 degrees?
Oh, 30 because I did some geometry. So the angle of the incline is 30. So if that's 30, then this must be 60, which means this must be 30 because that's perpendicular right there.
Oh, okay.
This is a little geometry. Okay? All right, in the y direction, how many forces are in the y direction? 2. We have normal force pointing up, and then what's our other y force? mgy. So this is going to be normal force minus cosine 30 mg. Those are the 2 y forces. Sum of the forces always equals ma, and that's a y acceleration. Now guys, the whole reason we tilted the xy, remember that's like your big thing for the incline. The reason we tilted this is right now. What can we do that's going to make this nice?
No y acceleration.
No y acceleration. Look, as the block goes down the incline, like this, the acceleration is perfectly what? X. Meaning, what's the y acceleration? 0. So we can go to the y acceleration and we can go, all right, y acceleration, get out of here. Here's 0. That's why we tilted the xy. So that goes to 0. Now you have 2 equations that'll solve the problem. That's how you do inclines. All right? So let's try one. Any questions? So let's try one here. incline part 2. Okay, so here's exactly what we just did, but since it's our first incline problem, no friction. The incline is frictionless. Instead of 30 degrees, it's 40 degrees. You're finding two things. What's the normal force on the mass, and what's the acceleration of the mass? Okay, so I'll give you 10 minutes to work on it. How many forces are on this block? 2 or 3? 2. There's only 2 forces on the block. What are the 2 forces? Gravity and normal force. That's it. No, and if friction were present, that would be a third force, but no friction yet. All right. The answers, if you do it correctly, the answer to the first question is 38.3 newtons. And then the answer to the second question is 6.4 meter per second squared. All right, so take 10 minutes, we'll solve it, and then that's our Friday. This diagram here, and I'm going to do my own. Okay, so putting an incline in. Here is our incline, box on the incline. Incline's 40 degrees. No friction present. So since no friction's present, we just have mg down, gravity pushing the box down. We have normal force perpendicular to the hill. Okay? We tilt the xy to make things simple. X goes like that. Y goes like that. Let's put our sign convention in as well. Make the direction of motion positive. So it goes like this. So there's our sign convention. And then here's the xy axis. All right, normal force, nice. Perfectly y. mg has to be broken apart. So let's show that. So mg is going to be like this. We show y component. That right there is mgy. This right here is mgx. With geometry, we can show that this angle in here, what's that going to be? 40 degrees, right? I'll show it again real quick. Here's how you figure it out. You got this triangle right here. Look, you got a triangle right here. So this is a right angle. So what's this angle up here? 50. That's got to be 50, which means the angle breaking mg apart has to be 40. Okay, now let's sum forces. So we did free body diagram. Now we sum forces. So summing forces x, summing forces y. We only have one force in the x direction, which is this guy right there, mgx. So how do we get mgx? Well, we got to use trig. mgx is going to be sine 40 mg, right? Sine because it's opposite the 40, right? Here's our right angle right there. mg over here is the hypotenuse. So we're solving for the opposite component. So here's what it looks like. You plug in here, you go sine 40 mg. That's the only x force for this problem. So sum of the forces always equals ma, where that's our x acceleration. Boom. All right, in the y direction, how many forces are in the y direction? 2. The y direction's this. There's the y direction. We have 2 forces in the y, normal force and mgy. Okay? So we go normal force plus, that's pointing positive, then minus, now what do we say about mgy? Cosine 40 mg. Right? That's mgy, cosine 40 mg. Any other y forces? Nope. Sum of the forces always equals ma, but that's a y acceleration. Okay? What's the acceleration in the y direction? 0. There is no y acceleration because the acceleration is only in the x. Okay? So the y acceleration goes to 0, so I'm going to erase that. This goes to 0. And now we have equations that'll solve the problem. So finding the normal force. The first question is find normal force. So you take this equation here. Normal force is going to be cosine 40 mg. So plugging numbers in, cosine 40, the mass is 5. In class, I use gravity as 10. When you guys are doing the homework, use 9.8 because that's what the book uses. But using gravity as 10, you get 38.3 newtons. Okay? Oh, and by the way, a quick comment about normal force. At this point in the class, some of you have memorized incorrectly that normal force equals mg. I've heard so many kids say that over the years. They're like, oh, wait a minute, I thought normal force was mg. How many of you had that? I know so, at least yeah, there's kids that, at this point in physics, kids are like, wait a minute, I thought normal force equals mg. Look, there's only one time when normal force equals mg, and that's when you have an object on a flat surface. So here's an object sitting on a table with no other vertical forces. So you got mg down, normal force up, then the normal force equals mg, right? But if there's other vertical forces, like if something's pulling at an angle here, you know, then normal force will not be mg, especially not on an incline. Okay, how do we get the acceleration? So this came out here to be 38.3 newtons. So how do we get acceleration? From the x equation. Now look, what happens to the masses in this x equation? The m's cancel, so we get a equals sine 40 times g. So if we're using g as 10, this comes out as 6.4 meter per second squared. That's the acceleration down the hill. All right, any questions? Very nice.